Hello. Here we're going to discuss Chapter 10, Section 2. So Section 2 of Chapter 10 is titled Arclength and Parametric Curves. So in general, a parametric curve is usually represented by two parametric equations. This is in two-dimensional space. And so usually we have C means the curve. It's represented by two parametric equations, x equals f of t and y equals g of t, where t is the parameter, and t is going to be bounded by alpha and beta. So for example, if we kind of review pre-calculus, for example, a circle of radius 1, we know its Cartesian equation is x squared plus y squared equals 1. But its parametric equation is x equals cosine theta, y equals sin theta, and theta this time is the parameter. And theta, since we're doing for circle, we go from 0 radian to 2 pi radians. So theta is the angle, and the angle is between 0 and 2 pi. So for circle, for example, we have these two parametric equations that represent the circle, this circle. Its Cartesian coordinate is x squared plus y squared equals 1, and its parametric equations are x equals cosine theta, y equals sin theta, and theta is between 0 and 2 pi. But here we're going to try to find the arc length of a curve. That curve is given in terms of parametric equations. So two parametric equations that describe the curve. And the parameter t is between alpha and beta, and we still have the same idea of finding the arc length of this, the length of this arc. So when you the curve is given by two parametric equations, and the parameter is also bounded by alpha and beta. So to find the arc length of such a curve, you use this formula. L, which is the arc length equals to the integral from alpha to beta of a square root of, so you have x prime of t squared plus y prime of t squared. You put them under the square root and then dt. Because x is f of t and then y is of g of t, so sometimes you'll see x prime being replaced by f prime of t because of this. And then y prime is replaced by g prime of t. And then x prime is actually dx dt. And then y prime is dy dt. So you can also see this version of the formula. All three just mean the same thing. Okay, it's just different notation. Okay, so let's take an example. So here they give us the curve x of t, which is t squared plus 2t minus 44. Y of t is a t squared plus 2t minus 1. And then the t is bounded by 0 and 9. So 0 and 9. So alpha is 0, beta is 9. So when you look at the formula, we know first we need to find the derivative of x of t. Since x of t is a t squared plus 2t minus 44, you take the derivative of t squared, you get 2t. Derivative of 2t, you get 2. Derivative of 44 is 0. So and then the formula says to square x prime of t. So we're going to square this. So here I kind of factor out 2 from here. Now when you square 2, you get 4, and then times quantity t plus 1 squared. When you expand it, you get 4 times quantity t squared plus 2t plus 1. Distribute 4, you get this. Similarly, y of t is t squared plus 2t minus 1. when you take its derivative, you get a 2t plus 2. You factor out the 2 and then you square, you get the same thing. So we write down the formula, which is this we're going to follow. So x prime of t square is what we got here, and then y prime of t square we got there. So we plug those into the formula. But I went back to this notation. Okay. I went back to that notation. So instead of writing 4t squared plus 8t plus 4, I write 4 times quantity t squared plus 2. And similarly, y prime of t square is 4 times quantity t squared plus 1 square. So when you add the 2, you get 8 because you have the same thing. So you get 8 times quantity t plus 1 square. It's easier to do like this. Then when you take the square root, you take the square root of 8, and then you take the square root of quantity t squared plus 1 square. So the square root of the square root will remove 2. So here you get only t plus quantity t plus 1. And clearly sometimes you write the square root of 8 as a 2 times square root of 2. So that's what you're going to integrate. Okay, so you're going to integrate from 0 to 9. So we because 0 to 9 were the boundaries of the parameter t they gave us. So t is 2 times square root of t is a number. You can bring it outside the integration. Now when you integrate t, you get the t squared over 2. When you integrate to 1, you get t. Then you're going to evaluate this quantity at 0 and 9. First, you plug in the upper limit of integration. So you plug in 9 for t into this expression, minus, then you plug in 0 for t into the same expression. But all of those are just a bunch of zeros. So you get 9 squared over 2, which is 81 over 2 plus 9. Find common denominator, you get 99 over 2. And then times 2 squared root of 2. Simplify it till you get the answer. So L is 99 times square root of 2. So we go to the second example. We have this time, we have this curve represented by x of t equals 1 plus 3t squared, y of t equals 4 plus 2t cubed. The interval, the parameter t is bounded by 0 and 1. So we are asked to find the arc length. So again, we take x of t, we take its derivative, we get 6t. Now we square to get 30/60 squared. Y of t is 4 plus 2t cubed. You take its derivative, you get 60 squared. And then when you square it, you get 30/60 to the 4th. You add the 2. X prime of t squared plus y prime of t squared give us 30/60 squared plus 30/60 to the 4th. We can factor out 30/60 squared to get 30/60 squared times quantity 1 plus t squared. We take the square root. So when you take the square root, you will take the square root of 30/60 squared, which will give you 60, and then 1 plus t squared remain under the square root. We use this pre-calculus property. When you have the square root of a times b is the square root of a times square root of b. So that's what you're going to integrate. You're going to integrate 60 times the square root of 1 plus t squared from 0 to 1. So this then, to do it, we use the u substitution. We're going to let the u be 1 plus t squared, so that du is a 2t dt. And so what I did here was I'm going to take this 6, rewrite 6 as a 3 times 2t. Okay, 6t is a 3 times 2t, so that they can match with 2t here. But I want to change this t integral in terms of a u integral. So we have also to change limits of integration. So when a t is 0, so we plug in 0 for t here, we get u equals 1. When t is 1, you plug in 1 for 2, you get u equals 2. So you're going to integrate from 1 to 2. In terms of u, since 1 plus t squared is u, so you're going to have the square root of u. As we said, 3 times 2 is a 6. So I can rewrite this as a 3 times 2t dt. The reason I want to have a 2t dt because 2t dt has a name, that's du. So I can just call this du, and then the 3 remains there. So I have now the u integral. I can move a 3 outside and then integrate the square root of u. First you change it as a square root of, you change it as u raised to a half. and then you use the power rule of integration to add 1 to a half, and then divide by 3 halves. And again, when you're dividing by a fraction, you can flip and multiply, get to 2/3 from 3 halves. Simplify 3, and then plug in a 2 for u, and then 1 for u, and then take the difference. And then you end up with, so 2 raised to 3 halves can also be written as 2 times square root of 2. 1 raised to 3 halves is just 1. So you get the answer.